Next topic is angle between two lines in terms of direction cosines. So question is find the angle between two lines, theta between two lines whose direction cosines are L1 M1 N1 and L2 M2 N2. Another question is what? Whose direction cosines are L M N and L dash M dash N dash. So there are two lines. Suppose L1 and L2 are that two lines whose direction cosines are L1 M1 N1 and L2 M2 M2, and theta be the angle between them. So here in the figure, this L1 line L1 and L2 are shown, and theta is the angle between them, and the direction cosines of the line L1 are L1 M1 N1, and the direction cosines of the line L2 are small L2 M2 N2. Let P and Q be the point on the line L1 and L2 such that OP is equal to 1 and OQ is equal to 1 unit. Okay. So P is the point on the line L1 and Q is the point on the line L2 such that the distance between OP is 1 and OQ is also 1. Okay. OP is 1 and OQ is 1. Hence, L1 is cos alpha 1 because suppose alpha 1, alpha 2, alpha 1, beta 1 and gamma 1 be the direction angles of line OP, and alpha 2, beta 2 and gamma 2 be direction angles of line OQ. Then L1 is cos alpha 1, M1 is cos beta 1 and N1 is cos gamma 1, and L2 is cos alpha 2, M2 is cos beta 2, N2 is cos gamma 2. That is alpha 1, beta 1, gamma 1 are the direction angles of line OP, and alpha 2, beta 2 and gamma 2 be the direction angles of line OQ. That is the line makes an angle alpha 1, alpha 2, alpha 1, beta 1 and gamma 1 with positive x-axis, y-axis and z-axis, the line OP. Similarly, the line OQ makes an angle alpha 2 with x-axis, beta 2 with y-axis and gamma 2 with z-axis. Now we have cos alpha 1 is equal to x by OP because the previous proof. What is cos alpha? Cos alpha is x by r. What is r? X means the coordinate of the point P and r means what? The distance between OP. X by OP. What is cos alpha? X divided by OP. Similarly here cos alpha is cos alpha 1. The notation for line OP are what? Alpha 1, beta 1, gamma 1. So cos alpha 1 is what? X divided by the x means coordinate x coordinate of the point P divided by OP, and the OP is 1. So x is what? Cos alpha 1. Similarly cos beta 1 is y, cos gamma 1 is z, and therefore the coordinate of the point P which are x, y, z are what? Cos alpha 1, cos beta 1, cos gamma 1. So these are the coordinate of the point P because OP, distance OP is what? Is 1. So now by using the previous proof of this, what do we have? Cos alpha is x divided by OP, but OP is what? 1, and so cos alpha 1 is x, cos alpha 1 is x, cos beta 1 is y, cos gamma 1 is z, and these x, y, z are the coordinate of the point P. Therefore the coordinate of the point P is another form is what? Cos alpha 1, cos beta 1, cos gamma 1. Similarly the coordinate of the point Q are what? Cos alpha 2, cos beta 2 and cos gamma 2 are the coordinate of the point Q. So similar to coordinate of the point P. Then the distance between P and Q, this distance by using distance formula PQ, the distance between P and Q is what? Cos in root cos alpha 2 minus cos alpha 1 bracket square plus cos beta 2 minus cos beta 1 bracket square plus cos gamma 2 minus cos gamma 1 bracket square by using the distance formula. X2 minus x1 bracket square, y2 minus y1 bracket square, z2 minus z1 bracket square. And if we take the square of LHS, then remove the sign or root sign of RHS. So we have this. After removing the sign, then the square of this bracket, these brackets. So square of this bracket is was cos square alpha 1, right? Cos square alpha 1, not cos square alpha 2. Okay, cos square alpha 2. And multiplication of these two, and it's double, minus 2 cos alpha 1, cos alpha 2, and cos square alpha 1 plus cos square alpha 1. Similarly, square of this bracket, these three terms, and the square of this bracket is what? cos square gamma 2 minus 2 cos gamma 1 cos gamma 2 plus cos square gamma 1, and then write this cos square alpha 2 alpha 1 cos square beta 1 cos square gamma 1 in one bracket plus cos square alpha 2 plus cos square beta 2 plus cos square gamma 2 in another bracket, and from these three terms, this take minus 2 as a common, we have cos alpha 1 cos alpha 2 plus cos beta 1 cos beta 2 plus cos gamma 1 cos gamma 2 in bracket, and then cos square alpha 1 plus cos square beta 1 plus cos square gamma 1 is 1, and similarly cos square alpha 2 plus cos square beta 2 plus cos square gamma 2 is 1 by using this, because L square plus M square plus N square is 1, or cos square alpha plus cos square beta plus cos square gamma is 1. So we have the answer 1. Of this bracket is 1, the bracket of this answer is 1 minus 2, and cos alpha 1 and cos alpha 2 means L1 and M1, L1 and L2, the notation. L1 means what? Cos alpha 1, and cos alpha 2 means L2. So in new notation what we have? Cos alpha 1 into cos alpha 2 means L1 into L2. Similarly cos beta 1 into cos beta 2 means M1 into M2. And cos gamma 1 into cos gamma 2 means N1 into L2. And therefore 2 1 plus 1 is 2 minus 2 L1 L2 plus M1 M2 plus N1 N2 by cosine rule in triangle OPQ. So I apply the cosine rule for this triangle OPQ is what? Cos theta is cos theta, that is the angle between these two lines. Cos theta is OP square plus OQ square minus cos theta is what? OP square plus OQ square minus QP square, right here, minus QP square, right here, QP. OP square plus OQ square adjacent side square, and then minus OQ square divided by 2 times OP into OQ. So this is the cosine rule. Cos theta is what? OP square. Theta is this angle. So OP square plus OQ square minus QP square divided by 2 times OP into OQ. But OP and OQ are 1, so substitute that values. So here is the proof. Then OP is 1, so 1 square is 1, OQ is 1, 1 square is 1 minus 2, and OP, here write QP, and QP, value of QP is this, QP, PQ or PQ, that is, it is right, QP. So QP square or PQ square is this, 2 in bracket, right, in bracket 2 minus 2 in round bracket, L1 L2 plus M1 M2 plus N1 N2, the value of QP, right here, QP. Okay, square bracket complete. Then 2 divided by OP is 1, OQ is 1. So 2, 1 plus 1 is 2 minus the effect of this minus sign, minus 2, right, minus 2, here the addition is 2, minus 2, right, minus 2, then plus 2 times L1 in bracket L1 L2 plus M1 M2 plus M1 N2. So, and 2 minus 2 is 0. So here is the mistake, right? 2 minus 2 and plus then plus 2 in bracket this, and then 2 minus 2 becomes 0, and this 2 by 2 get cancelled, and therefore we have cos theta is equal to L1 L2 plus M1 M2 plus N1 N2, and this is the formula to determine the angle between two lines. What is the formula? Cos theta is L1 into L2 plus M1 into M2 plus N1 into N2. So this is the angle between two lines in terms of direction cosines. That is theta means what? We have theta as cos inverse of this quantity. So if the notations are L M L and L dash M dash L dash, then cos theta is what? L L dash plus M M dash plus L L dash. So this is the proof of this theorem, that is the angle between two lines in terms of direction cosines. So these L1 M1 N1 and L2 M2 are the direction cosines. That is, if we know the direction cosines of two lines, then we can find by using this formula the angle between that two lines. Suppose that two lines L1 and L2 are perpendicular to each other, then theta is pi by 2. If the two lines are perpendicular, then theta is pi by 2. If L1 and L2 are perpendicular, then theta is pi by 2. The angle between L1 and L2 is pi by 2. And then substitute theta as pi by 2, what we have? Cos pi by 2 is equal to L1 L2 plus M1 M2 plus N1 N2. And cos pi by 2 cos 90 is 0. So we have L1 into L2 plus M1 into M2 plus N1 into N2 is equal to 0. And this is the condition of perpendicularity. When the two lines are perpendicular, if the two lines, the direction cosines of the two lines are L1 M1 N1 and L2 M2 N2, then if L1 into L2 plus M1 into M2 plus N1 into N2 is equal to 0, then the two lines are perpendicular. Similarly, the conditions for parallel is L1 by L2 is equal to M1 by M2 is equal to N1 by N2. That is, the direction cosines are in proportional, then the two lines are parallel. So this is the condition of two lines to be parallel. And this is the condition that two lines to be perpendicular. This is the condition of perpendicularity. This is the condition of parallelity. The third note is let A1 B1 C1 and A2 B2 C2 be direction ratios of the line L1 and L2. Then what is L1? L1 is A1 divided by root A1 square plus B1 square plus C1 square. M1 is what? This is B1 divided by root A1 square plus B1 square plus C1 square. And N1 is what? C1 divided by root A1 square plus B1 square plus C1 square. Similarly, L2 is what? Small L2. That is the relation between direction cosines and direction ratios. The L2 is A2 divided by root A2 square plus B2 square plus C2 square. M2 is B2 by A2 square plus root A2 square plus B2 square plus C2 square. M2 is what? C2 divided by root A2 square plus B2 square plus C2 square. And then cos theta is L1 L2 plus M1 M2 plus N1 N2. Substitute the values of L1 M1 N1 and L2 M2 N2. We have this. And then we have the LCM as root A1 square plus B1 square plus C1 square, root A2 square plus B2 square plus C2 square, and numerator is A1 A2 plus B1 B2 plus C1 C2. So cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 divided by root A1 square plus B1 square plus C1 square, root A2 square plus B2 square plus C2 square. So this is the formula to obtain the angle between two lines in terms of direction ratios. So A1 B1 C1 and A2 B2 C2 are what? Are the direction ratios of the line. So the same formula, this is the formula in terms of direction cosines. Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. And this is the formula to obtain the angle between two lines in terms of direction ratios. A1 A2 plus B1 B2 plus C1 C2 divided by root A1 square plus B1 square plus C1 square, root A2 square plus B2 square plus C2 square. So these are the two formulas in order to determine the angle between two lines. That is, if we know the direction ratios of the two lines, then use this formula. And if we know the direction cosines of the two lines, then use this formula. Okay. So the question is, find the two lines whose direction ratios are 2 minus 2 1 and 2 1 minus 2. Find the two lines whose direction cosines are. Find the angle between two lines, right? Correct the question that find the angle between two lines. Find the angle between two lines whose direction ratios are 2 minus 2 1 and 2 1 minus 2. That is, we are given A1 B1 C1 and A2 B2 C2, the direction ratios of two lines. And now we have to find the angle between that two lines. So cos theta is equal to, the formula is A1 A2 plus B1 B2 plus C1 C2 divided by root A1 square plus B1 square plus C1 square, root A2 square plus B2 square plus C2 square. And then write the values of A1 B1 C1 and A2 B2 C2. We have this answer. 0 by root 9 into root 9, that is 0 by 9, that is 0, and means cos theta is what? Theta is cos inverse 0, and cos inverse 0 is pi by 2. That is, the given two lines are perpendicular to each other. The given two lines are, angle between the given two lines is pi by 2, means the given two lines are perpendicular to each other. Show that the two lines whose direction ratios are 2 minus 2 1 and 2 minus 1 minus 2 are perpendicular. So when two lines are perpendicular, if A1 A2 plus B1 B2 plus C1 C2 is 0. So show this A1 A2 plus B1 B2 plus C1 C2 as 2 into 2 minus 2 into minus 1 and plus 1 into minus 2, and the answer is 0. So the two lines, the given two, these two lines are perpendicular to each other. Two lines are parallel. The condition for two lines parallel is this. So in order to show the line two lines are perpendicular, show that a1 a2 plus b1 b2 plus c1 c2 is equal to 0 if the direction ratios are given, and if the direction cosines are given, that is l1 m1 n1 and l2 m2 n2 are given, then show L1, L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Then we say if this is equal to 0, that L1, L2 plus M1, M2 plus N1, N2 is 0, then we say the two lines are perpendicular. Or if the A1, A2 plus B1, B2 plus C1, C2 is 0, then we also say the two lines are perpendicular. So if the two lines are having direction ratios 2 minus 2 1 and 2 minus 1 minus 2, then the two lines are perpendicular because a1 a2 plus b1 b2 plus c1 c2 is 0. So next example is find the angle between two lines whose direction cosines are connected by this. So we can find the angle between two lines if we know the either their direction ratios or direction cosines. If we know the direction ratios of the two lines, then use this formula. Cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by this root a1 square plus b1 square plus c1 square root a2 square plus b2 square plus c2 square if the direction ratios of the two lines are given. And if the direction cosines are given or known, then use the formula cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. So the next example is this, that find the angle between two lines whose direction cosines are connected by direction cosines are connected by these two relations. So we are given the direction ratios, but not directly. Indirectly, we are given the direction cosines. Direction cosines. So in order to find the direction cosines or direction ratios, solve these two equations and find the direction ratios or direction cosines, and then find the angle between two lines. So we'll see this problem in the next lecture.